Howdy guys, this video will cover 2-3, topic 2-3, patterns and non-linear functions, which were covered on Wednesday, September 16th, 2015, right? No, wait, it was Tuesday, September 15th, 2015, there we go. Okay, so here we go. We will be able to identify and represent patterns that describe non-linear functions. Alright. So, let's get that. Oh, our essential understanding, what we need to know by the end of this topic, just like linear functions, nonlinear functions can be represented using words, tables, equations, sets of ordered pairs, and graphs. Alright? So, here's the first problem. Problem 1. Classifying functions as linear and nonlinear. So first, the pizza. The area A in square inches of a pizza is a function of its radius r in inches. Graph the function shown by the table. Is the function linear or nonlinear? So it says to graph. So we need a coordinate plane. We have our y-axis and our x-axis. So for the x-axis, we're always going to usually be the left side of the column, the left side of the table. And then for the y-axis, it'll usually always be the right side of the table. So for x, our x values are going to be 2, 4, 6, 8, and 10. So let's go ahead and mark those. So 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. All right. And then here, our y column, our largest number is 314. So let's go ahead and get increments that are large enough to get to 314 up here. Or 350, 325, whatever. And I think I want to go by 50s. So we'll go 50, 100, 150, 200, 250, 300, 350. Good. So we're going by increments of 50. 250, 200, 150, 100, 50. Okay. And then the corner is obviously 0. Alright, so now we can do what we were asked, which is graph the function. Now, with the linear functions, we know that we need 2 points to make a line, to make a straight line. But this, I can already tell, is not linear. And for a nonlinear function, we need to plot all the points to see the curve that it creates. So let's plot every single one of these 1, 2, 3, 4, 5 points. Okay, so let's start with 2 and round up to 13. So 213. Okay, which is approximately half of 25, right? So if that's 25, then that's going to be approximately 13. So 213 is right there. All right, now for 50, that'll be easy. So go to 50 and then go across the floor. Boom. Well, actually, we should be doing the opposite. We go to 4 and then go up to 50. For 6, 113, let's see. 113, that's like half of 25. So if we go to 6 and then go up to about 113, approximately right there. That's a little higher than that. Okay. 8. So 8, 201. I can just round that to 200. So 8, 200. And then lastly, 10, 314. So that's 325. That's 312. So somewhere over there. So 10 and right there. That's good enough. That's ugly a little bit. Okay, that's a little better. Okay, so now we have all 5 points, so now we can draw our line. So pretty much going to just connect all these dots. Okay, and that there is, it's, pretty not straight. It's curved. So since it's curved line, that means it is non-linear. Okay, so non-linear. And if it's a straight line, it is linear. All right, so let's go ahead and move on to problem 2. So problem 2, representing patterns and non-linear functions. So the table shows the total number of blocks in each figure below as a function of the number of blocks on one edge. What is a pattern you can use to complete the table? Represent the relationship using words, an equation, and a graph. All right. So we need to go ahead and fill these blanks in with numbers. And find the relationship using words, an equation, and a graph. Okay, so 1 goes to 1, all right? 2 goes to 8, 3 goes to 27. Now, I already know what's going on here, okay? Let's see if we can figure it out too. Let's see if I can get y'all to figure it out too. So we are finding the pattern between the total number of blocks given the number of blocks on one edge. Okay? So the number of blocks on one edge. Here we have one edge and we have one block. Here we have two edges, but we have 1, 2, 3, 4, 5, 6, 7, 8 blocks. Here we have 1, 2, 3 edges, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9 times 1, 2, 3. So 9 times 3 is 27 blocks. So that's why we have 1. That's why we have 1, 1, 2, 8, 3, 27. Now, let me give you a hint here. We have a cube. These are cubes, and we're finding the total number of blocks inside that cube. So let's say that the edges, this edge is a length of 3, but the total number of blocks inside is 27. And I'm thinking of shapes here. We're finding what's inside of something. Whenever we find what was inside of something, that's called the area. Okay, so the area of a cube is what we're looking for. Area of a cube, or that's what the total number of blocks is. And then the number of blocks on edge is the side length. And if y'all remember from, I think last year, y'all covered this a little bit, the area of a cube is the side length to the what power? How many sides are there on a cube? You have the width, you have the length, and you have the height. So 1, 2, 3. Multiplying the side length by itself 3 times. So s cubed. So area of a cube is s cubed, meaning the side length cubed, multiplied by itself 3 times. So, I probably just gave that away, but yeah. Let's see. So here we go. So 1 cubed is 1 times 1 times 1, which equals 1. 2 cubed is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. Check. 3 cubed is 3 times 3 times 3. So 3 times 3 is 9. 9 times 3 is 27. Check. Okay, so it checks out. So our number of blocks on edge gives us the total number of blocks by cubing the number of blocks on edge, because we're finding the area of a cube given its side length. So if we're going to cube 4, 4 times 4 times 4, so 4 times 4 is 16. 16 times 4 is 64. So that'll be 464. And lastly, 5 cubed is 5 times 5 times 5. 5 times 5 is 25. So 25 times 5 is 125. And that'll be 5 and 125. Here we go. Okay, so we finished the table. We completed the table. So now let's go ahead and describe this using words. And to describe this using words, we're going to pretty much take our, and guess what, guys? We already found the equation too. A equals s cubed is the equation. Because, yeah, the area of a cube is what we're really finding here. So let's go ahead and convert this equation into our words. So we know that A is your output, and S is going to be your input, x. So y equals x cubed. Now, in order to convert that using words, let's look at our variables and our equal sign and our cubed and everything, and we need to convert it to words. Yeah, okay, so I can't really say much more than that. So y is right there, total number of blocks. So instead of y, we're going to write total number of blocks, and then equal sign is you write is for an equal sign. So total number of blocks is, and then we have x, and x is number of blocks on edge. Okay, so then we would write total number of blocks is the number of blocks on edge and then lastly we have this 3 here, which stands for cubed. So that 3 there stands for cubed. So that's what we're going to write afterwards. So the total number of blocks is the number of blocks on edge cubed. All right, there we go. So we have the equation done, which is right here. Here's the equation. We have the words done. So all we need is a graph. So let's go ahead and do the graph here real quickly. So we have, what was that again? We had 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. And then, oops, wrong way. 1, 8, 27, 64, 25. So 1, 8, 27, 64, 1, 25. So let's go ahead and plot those points to make our graph. That's the x, that's the y, that's 0. Okay, so our x-axis will have 1, 2, 3, 4, and 5. So 1, 2, 3, 4, and 5. And our largest number is 125. So we need increments that will go to 125, which I'm going to go ahead and do 25. So 25, 50, 75, 100, 125. Now let's plot all the points. So our first point is 1, 1. So 1, and then up a little bit. 2 is 8, so 2 and up a little bit more. 3 is 27, so a little bit above 25. 4 is 64, so somewhere between 50 and 75. We're just guesstimating here, guys. Doesn't have to be that accurate. And then 5, 125. So after you have all your points, go ahead and connect your dots. Well, as best as possible. So there we go. There's our curve. So it's there's our line, which is curved. So it's non-linear. And if there's any breaks in this video where something seems confusing, I apologize. I was interrupted 3 times during this video, so I had to cut and paste some parts. So anyways, thanks for watching, and see you all in class. Bye.